All right, ladies and gentlemen, welcome back. We are on worksheet 8-2, okay? Multiplying rational expressions, okay? So rational expressions, again, are just fractions with polynomials in the numerator and or denominator, okay? So we're gonna have fractions with x's in it, all right? So the big thing to remember here, okay, is that you are going to, the steps here, are going to be, and it's going to be just like simplifying, you'll see. But the first thing you're going to do is factor, and then the second thing you're going to do is cancel. Then third thing is you're going to multiply across. Okay, so across like this, all right? So if you think back about it, like way back in the day, I did an example, like you had, 3/8 times, and we did this yesterday, 4, let's say, 15ths, okay? What you can do here is, you can multiply across like they did here, but the easier thing to do is to cross cancel, okay? So you can cancel from numerator to denominator, all right? That's the most important thing. So if I take a look here, it can be numerator to denominator within the same fraction or across, right? So top to bottom here, numerator to denominator. So if I look 3 and 15, 3 and 15, 3 goes into 15, so this is a 1, and this becomes a 5, okay? Then 4 and 8 share a common factor, right? 4 actually goes into 8. It is a common factor. So this becomes 1. This becomes 2. And then, like I said, we multiply across. So we're going to do 1 times 1 over 2 times 5, which means our final answer is 1/10, okay? And that's our simplified answer after we perform the operation of multiplication, all right? So we're going to do the same thing, except now we're going to do it with x's, okay? So if you take a look at our first guy here, all right? These are all monomials, so I can't really factor monomials. So what I'm going to do is I'm going to go ahead and cancel common factors here, all right? So if I look here, similar to what we just did, right? 4 goes into 8. So that 4 and that 8 are both, they both have a factor of 4. So this becomes 1 and that becomes 2, okay? Then if I look, and I'm just looking at the numbers first, okay? Then if I look at the 3 and the 9, right? Numerator to denominator, this 3 is actually a factor of 9. So this becomes 1. And then that becomes 3, okay? Now, if you look, we also have all these x's, right, don't we? Okay. Now, when I have monomials, I usually just reduce the numbers first, and then I multiply across, because it gets a little bit crazy. So if you look here, I reduce the numbers. Now I'm just going to multiply across. So this is 1 times 3. So really, you have 1x squared over 1 times 3x over 2x to the 5th. So that gives me 3x to the 3rd over 2x to the 5th. Now, the 3 and the 2, right, I already reduced all the numbers, right? So 3 and 2 can't be reduced. But if you look at your x's, you can see, right, this x cubed, right, I can subtract these two exponents, and I end up with 3 over 2x squareds, right? Because the x to the 3rd cancels with this, and I'm left with x squared on the bottom, okay? So when I have monomials, I reduce, okay, and cross cancel the coefficients, then I multiply across, and then I do the variables, okay? Now if you look at this guy, very different, right? We do have two monomials here, but we have binomials, okay? So I cannot cancel a 9 with a 12, all right? Because that's not a 9, it's an x squared minus 9. So anytime I have anything other than a monomial, I have to factor first, okay? So if you look here, this guy's just a 3x. This one, right, I have a GCF, right? I have two terms. So the first thing I always look for is a GCF. So if this is 4x minus 12, I can actually take a 4 out, can I? Out of both of those terms, so this becomes 4 parentheses x minus 3, okay? Times, then I look at this guy. Well, remember our factoring steps, right? The first thing is GCF. The second thing is difference of perfect squares, which we talked about yesterday. You don't see this as much, but if I look at this guy, this is screaming to me as DPS because it has, right, two terms, subtraction, and then everything is a perfect square, right? Because x squared literally says squared, and then the square root of 9 is 3. So if you remember, when you factor something like this, x squared minus 9, which is DPS, always you kind of square root each of these, and you get x minus 3 and x plus 3. The only difference, right? So square root of x is x and x, square root of 9 is 3 and 3, and then the only difference is the plus or minus. So I'm going to bring that down. And then my denominator is just x because that's a monomial. So now I look, all right, everything has been broken down into its parts, okay? And then this is the very satisfying part where you have common factors that you can cancel. So if you look, this has a binomial factor of x minus 3 in the numerator, which can match up to this factor of x minus 3 in the denominator, okay? You're cross-canceling. Then since these are monomials, right, and there's nothing attached to them, I can cancel this x with that x, right? Just like I did here when everything was a monomial. So 1x over an x cancels to 1. So this becomes 1, that becomes 1. Everything cancels to 1, right? So now I end up with 3 times x plus 3 over 4 times 1, which is just 4. And then you don't have to distribute the 3. You're good. That's it. That is your simplified answer, okay? So you're always going to factor, all right? Just to add here, our first step will be GCF. Our second step will be DPS. And then our third type of factoring is our trinomial, or like as some of you call it, IM, okay, which we've been doing, all right? So let's take a look here. Here's our practice. So these are all multiplication. So today our focus is just multiplication. So you're going to factor, then cancel. Factor, then cancel, because I can see, unlike number 1, right, up above, these all have either binomials or trinomials, okay? All right, so this guy's nice because the 1 can't be factored. That's a monomial. If I look at v minus 9, that can't be trinomial because it's got two terms. But GCF, is there a GCF there? Can I pull anything out? No. Can't divide anything out of V or the minus 9. And then this is not DPS because everything is not a perfect square. There's no V squared here. It's just V. So this guy stays that. You don't have to factor that. Then I look at this guy. It has, both of these have two terms. So we can't do trinomial at all. All right, so that's the first thing. You just eliminate that. GCF, if I look, well, that 10 and that 90 look like I can take a 10 out. So factor out the 10, and then I get 10. Don't forget to include the GCF outside. That's important. Every part should be there. So 10 V minus 9. And then down at the bottom, so this guy was GCF, and you're going to use GCF a lot, I'll tell you right now. This one, well, that's 9v squared, right? Subtraction, right? This looks pretty good for difference of perfect squares, maybe, or GCF. But that 72 is not a perfect square, so it's got to be GCF. So if I look here, always try and think about the smaller number. Is that a factor of the larger? So 72 divided by 9. Oh, look at that. That's 8. Okay. So that means we're going to do 9v squared minus 72v take a 9 out, and then if you look, they each have a v in them, at least one v, so I'm going to take that out. So then I'm going to pull the 9v outside, and then 9v squared divided by 9v leaves me with just a v. And then minus 72v, the v's cancel, and then I just get minus 8, because you saw, remember, that 72 divided by 9 is 8. So now I've factored everything. Now I'm going to go to my second step, which is cancel, right? So that guy goes, right? Numerator to denominator, 1 for 1. So that's just a 1, that's just a 1. The 10, right? The factor, GCF of 10, can't cancel with this 9v. Right? And then there's nothing to match up, another binomial with the v minus 8. So I'm just left with 1, 10, and 1 in the numerator. So these all get multiplied. 1 times 10 times 1 is 10. 1 times 9v times v minus 8 is just 9v times v minus 8. You leave it in factored form. You're done. That's it. Okay? So that's our simplified answer. All right? Now, number 2. Let's look. We're going to factor everything we can here. So this is a plus 3, right? There's no GCF here, and that's not a perfect square. Same thing with a minus 5 times. Now this is 3 terms, so that's making me think maybe I am, but is there a GCF there? A squared minus, no. So this has to be a I am. So this has to multiply to 15 and add to negative 8. So my factors of 15, right, are 1 and 15. 2 doesn't go in, 3 and 5. And I think that's it. Okay, oh, so 3 and 5. And I need it to be negative, right? So everything is negative, and 2 negatives multiply to a positive. So this guy's going to become a minus 3 and a minus 5. All over a plus 3, because again, that cannot be factored. So now if I look, oh, look at that. Okay, so numerator to denominator, common binomial factors, okay? And then this a plus 5 cancels with that a plus 5, 1 for 1, right? So everything cancels to 1. So then if you look, I'm left in the numerator with 1 times a minus 3 times 1, which is a minus 3 over 1. So it's just a minus 3. That's it. Much nicer, right, than what we started with, okay? Let's look at number 3. Okay, number 3. 6 is a monomial. We can't factor that. R plus 8. So I've got 2 terms. Is there a GCF there? No, can't divide anything out. And it can't be difference of perfect squares because remember that has to be subtraction. Okay, so we can't be doing that. All right. So now that's just R plus 8 multiplied by, this guy is screaming to me that it's trinomial. Okay, there is no GCF. So this is what times what is 12. What plus what is negative 8. So factors of 12, right, would be 1 and 12, 2 and 6, 3 and 4, and I think that's it. So I think it's got to be 2 and 6. Both negative. So R minus 2 and R minus 6. And then over, this guy, well, first thing I'm going to look for is GCF. Well, 6 goes into 36. So here I can divide by 6, and then I'll get 6. Right, those cancel. R minus 6. Okay, so that's my factored form. Don't forget the GCF. That's important, okay? Because now if you look, can you see how you have that 6 pulled out, right? That's a factor out there, and that can cancel with that 6, okay? And then this r minus 6 in the denominator can cancel with this r minus 6 in the numerator. It doesn't matter that they're in the same fraction. That's okay too. So that's r minus 6, those go. So that's 1 and 1 and 1 and 1. So then I just have 1 times r minus 2 times 1. So it's just r minus 2 over r plus 8 times 1, which is r plus 8. Now remember, you might be tempted to cancel that r and that r, but those are not separated factors, right? It's r minus 2. Those are attached. So you cannot cancel those, okay? No slashing. All right. Put a star next to 4. 4 is a little tricky, okay? We're going to start it the same exact way, but there's one that'll catch towards the end. So if you take a look here, this is 1 over n minus 6, okay? Hopefully you recognize that this cannot be factored, okay? There's no GCF here, and it's not perfect, different to perfect squares. Okay, those are the only two I'm going to use, possibly because there's 2 terms there, but neither work. Then here, this one, GCF, 6 into 48, that works. Okay, so I'm going to do 48 minus 6n, divide out the 6, right? So 6, and then this becomes 8 minus, these will cancel, and we have 8 minus n, over, and then n minus 8 is not factorable, so you just leave it. Now, hopefully you're seeing that, okay, first of all, do not cancel that 6 with that 6, right? Because that negative 6, it's being subtracted, right, from that n. Those are attached, so you can't cancel those. However, these two are looking somewhat familiar, right? Similar, I should say. This has an n, that has an n. It has an 8 and an 8. Now, the only catch is they're not in the same order, so are they the same? Well, almost the same. Okay, these are what we call opposite factors. Okay, so can you guys see that note? Yeah, good. Okay, so opposite factors. That's when you have something where it's subtraction, and terms are in opposite order, okay? So if I have, and I'm just going to turn it into x's, 8 minus x and x minus 8. If you think about it, what that really means is I could turn this one, because you see how this is a negative x, I could pull a negative 1 out of that, okay? So if I factor out a negative 1, what that means is I'm really doing 8 minus x, and I'm dividing everything by negative 1. So now the 8 becomes negative, and the x becomes positive, okay? And then if I switch the order of this, because usually x comes first, I'll have x minus 8 and x minus 8. Now, hopefully you can see, right, that these actually are the same factor except for that negative 1. Okay, so if you have that negative, if you have 2 factors, right, they have the same terms, right, so same terms in the opposite order. It has to be subtraction, 8 minus x and x minus 8. These will always cancel, and you'll be left with a negative 1, okay? So what you're going to see me do is 8 minus n and n minus 1, n minus 8, to account for the fact that the only real difference here is their signs, okay? I'm going to cancel these two like I normally would, but I'm going to make this 1 and then the numerator negative 1, okay? So that's opposite factors, and that's a little bit tricky, okay? So that becomes negative 1. Then in my numerator, it's 1 times 6 times negative 1, so it's negative 6, over 1 times n minus 6, so it's n minus 6, okay? Again, you cannot cancel that 6, negative 6 with that negative 6, because this is attached to that n, okay? So that's your final answer, okay? And that's opposite factors. All right, so then this guy, last but not least, the last two, these two, monomial, so we can't factor. V squared minus 49, well, is there a GCF there? No. Is a difference of perfect squares? Well, V squared, yeah, minus subtraction. And is 49 a perfect square? Yes, it is. So that means this, I'm gonna square root the V squared and the 49, right? So then it becomes V and V, right? And then 7 and 7. And then the only difference in their signs is the plus and the minus. And that's my factored form. And then in the denominator, V minus 9, I can't GCF that because I can't divide anything out of V and 7. So it's just V minus 7. So now, numerator binomial matches up exactly with that denominator. I think that's all I can do. So that becomes 1 and 1. So now 1 times V plus 7 times 1 is V plus 7 over 6V squared. Okay, times 1, which is 6V squared. All right, last but not least, let's see, 1 and x plus 3. Those are not factorable, right? Hopefully you recognize that this guy is has a GCF of 2. So I'm going to take the 2 out. So 2x plus 3. And then x minus 7 is not factorable, right? So then if I look at all my oh, look at that, very nicely. Those two binomial factors are exactly the same. So then this becomes 1 times 2 times 1, which is 2. And then this becomes 1 times x minus 7, which is just x minus 7. So there are my simplified answers, okay? So your homework, okay, and the answer key is posted to Schoology, so you should be checking that, okay, in the homework answer key, okay? There's a folder there. If you take a look here, all right, this is our homework, all right? Just a couple things. This can be put over 1, and then you're just going to factor, all right? You can't really factor a 1, so don't worry about that. So same thing for this guy. That should be over 1, and that should be over 1. Here, if I take a look, put a star next to number 6. Okay, that's where we have our opposite factors, so just be aware of that, okay? So that one's a little bit tricky. All right, but again, please check your answers with the answer key. All right, and I hope you guys are doing well.